of Analogies in Physics, Part 6. Summary of the previous lecture. Some features that are not usually considered in physics, what the traditional formulation usually ignores. The role of the dual subdivision, classification diagram of various physical theories, such as hydraulics, steady flow, electrostatics, magnetostatics, statics of taut strings, elastostatics, and stationary thermal conduction. Including time in the diagram. What about time? Up to now, we have considered only the four space elements, that is, points, lines, surface, and volumes. And we have found that each global variable in space is associated with one of these four space elements. We propose to show that there is analogous association with the two time elements, the time instant and the time intervals. These will be denoted by capital letters in bold type I and capital T respectively. Notation. We use boldface type like we have done for space elements in order to denote simply with T in normal character the duration of the time interval T in bold. And these are the symbols. The notion of time. The notion of time arises from the notion of motion. Hence, we measure time counting the oscillation of a periodic motion, or the angular rotation of a wheel that has a constant angular velocity, typically a clock. Time is composed of two main elements, the intervals and the instants. It is a common practice to give a geometric representation of time, putting the instant into correspondence with the points of an axis, called time axis. This is an example. Yesterday, today, tomorrow, these are three time intervals. The instants are denoted with a bar, over bar, and the same is for intervals. It is spontaneous to divide into consecutive intervals, for example in days or in hours or in seconds. This division is represented on the time axis by adjacent segments that constitute the cell of a one-dimensional cell complex in time. This cell complex will play a pivotal role in the analysis we are doing. It is opportune that the label of each interval here, coincides with the label of the final instant. It's highly opportune, this notation. As the interval T1 has an extreme on the right instant I1. We call this a primal cell complex. We draw it in green and we put a bar over the letters, as we have done for primal cell complex in space. The mean velocity. The mean velocity of the car between two instants is of course given by this formula. Now the mean velocity coincides with the instantaneous velocity at some intermediate instant of the interval T1, T2. In particular, if the motion is uniformly accelerated, the mean velocity coincides with the instantaneous velocity of the central instant of the interval. Here you have the proof, the formula. The mean velocity coincides with the instantaneous velocity in the middle instant of the interval. the dual cell complex in time. For physical reasons, we shall explain in a moment, it is convenient to introduce a second subdivision of the time axis, considering the middle instant of each interval. This time instant will be called a dual instant, while the time intervals between the dual instants are called dual intervals. Note the remark, the dual complex in time is not expressly considered in mathematics and in physics. We shall show that it's implicitly used in dealing with the second-order derivatives. See the notion of acceleration later. It is also implicitly considered in the leapfrog algorithm of numerical analysis. Here you have the dual time intervals and the corresponding dual time instants. We will indicate the time elements of the primal subdivision by a bar, another bar, and those of the dual subdivision with a tilde over the letter, as we did for space elements. Inner and outer orientation of time elements. Each primal interval can be endowed with inner orientation, the one of the time axis, from the past toward the future. Here, from the past toward the future, exactly in the same orientation of the time axis. Each primal instance can be endowed with inner orientation, like points in space that are oriented as sinks. Here, the primal instants are oriented like sinks. The dual instants inherited the same orientation of the primal intervals. This can be visualized by an arrow crossing the dual instants. The dual intervals, here, the red one, inherited the same orientation as the primal instance. Two arrows converging to the time interval. But, if you remember, in the space element, the inner orientation of points is that of sinks. Incoming arrow is with an outer orientation of the dual element, that is volume, are with outward normals, outcoming arrows. Hence, the outer orientation of volume is opposite to the one induced by the inner orientation of points. To respect the sign convention actually in use also for time element, we must do the same for time elements. The outer orientation of the dual intervals is chosen to be opposite to the one induced by the inner orientation of the instant. Look here, the inner orientation of the instant changes signs and becomes the outer orientation of interval. Here, here. In this way, the dual instant are oriented with arrow outcoming instead that incoming. The arrow that are outgoing from the outer interval permits to find the incidence number between the bounding dual instant and the interval themselves. The incidence number is +1 or -1 according if the arrows are concordant or discordant. As happened in the primal complex, here are discordant, you have an incidence number -1, here +1. Velocity plays two roles, hence has two different associations. In physics, in particular in fluid dynamics, there are two descriptions. See slide 2 of 8, the lecture. the system or Lagrangian description and the spatial or Eulerian description. If we consider the velocity of a same particle at different time instant, we are in the system description. Since the velocity change sign under reversal of motion because it allows the time integration, giving the displacement, it is associated with time intervals endowed with inner orientation. If we consider the velocity of different particles at the same instant, we are in the spatial description. The velocity change sign under inversion of motion, but its integration in time is now meaningless. Hence, it is associated with time instant endowed with outer orientation. Hence, in the system description, or Lagrangian description, velocity is associated with primal time intervals. On the contrary, in the spatial description, also called the Euler description, velocity is associated with dual time instants. Please do not confuse the rate with the derivative and the definite time integral with the indefinite time integral. Here you have the same particle at different instants. This is a system description. Here you have the different time instant. Here we have different particle, but mapped at the same instant. And so you have a fixed instant and a variable point. For example, the Poiseuille motion in a tube. This is a spatial description. As you see, such two descriptions change the time, many time instant with one time instant, and one particle with many particles. Here you see the association with time interval endowed with inner orientation. The time integral is meaningful because it gives the displacement. Instead, in the spatial description, the velocity is associated with the dual time instants. The time integral in this case is meaningless. In both cases, the velocity changes sign under reversal of motion. Velocity, the system, and the spatial description. In order to measure the velocity of a particle, we need that elapsed a time interval, although small, in order to measure the displacement. For this reason, we say that velocity is associated with primal intervals, and we shall write v function of associated with t bar. That is, we put the symbol line over bar inside the square brackets. On account of the fact that the mean velocity is a time interval, can be approximated with the instantaneous velocity in the middle of the d interval, we will say that the instantaneous velocity is referred to the middle instant of the primal interval, that is, on the dual instants. Velocity is associated with primal time intervals and is referred to the dual time instants. That two association depends on the system or spatial description. Velocity of the system and the spatial description. The mean velocity relative to two consecutive time intervals are the velocity associated with a dual time instance. Hence, velocity that is associated with primal intervals may be referred to the dual instance. Velocity may be referred to the dual instance. Velocity that is referred with the dual instant. On the contrary, the mean velocity is referred to the primal intervals. Also here, the mean velocity is referred to the primal intervals, but the velocity, it is referred at the instant, the middle instant of the interval. This is not at all clear in the differential formulation because the limit process destroys the discrete subdivision, so hides the dual subdivision. It follows that the limit process hides the fundamental distinction between the association with primal intervals and the reference to the dual instance. Acceleration. In order to evaluate the mean acceleration, we must know the instantaneous velocity that are referred to the dual instant. Here, velocity is referred to the instant time t tilde one and the other. Now, the mean acceleration is the difference of the velocity divided by the extension t2 bar minus t1. Now, this acceleration is now associated with the middle instant of the interval, here, t1. As you see, the mean acceleration is associated with dual time interval and is referred to the primal time instance. To stress the importance of the distinction between primal and dual intervals, it is opportune to refer to the case of elastostatics that can be found in the lecture number 5. We need the primal time intervals, not time intervals, sorry, the primal space intervals as a dual space intervals. Some variables are associated with a primal space interval, and some other variables are associated with dual space elements. Radius vector, velocity and acceleration. The radius vector is associated with primal time instant. Primal time instant here. Radius vector. Velocity is associated with primal time intervals, on the contrary, because we need a small time interval in order to evaluate the velocity. Acceleration is associated with dual time intervals. Reversal of motion is not time reversal. The mental process of considering the reversal of order of events is called reversal of motion. If we do the filming of a person walking and after we run the film backward, we see that the displacements are inverted. This is a fundamental remark. During this vision, we always refer to the watch of our wrist that continues to go forward when we are having the motion that goes backward. Hence, we have the r is transformed into minus dr, but dt is unchanged, from which velocity becomes negative change sign, but because it is the infinitesimal displacement that changes sign. For this reason, in the reversal of motion, the velocity is inverted. Alternatively, one can perform the purely mathematical operation of changing t into minus t, hence dt into minus dt, but this is a purely mathematical operation, leaving dr, the displacement, unchanged. Also with this transformation, one obtains that the velocity is inverted. But this is a purely mathematical operation that is called time reversal. In the first case, you change the displacement, the r, into minus the r, but leave the time interval, the measure of the time interval dt, unchanged, because you compare the backward motion with your watch that go always in the forward motion. The operation of reversal of motion describes a process that can be visualized by filming the motion of a body and then running the film backward. In contrast, the operation of time reversal is a purely mathematical substitution of the variable t into minus t. In spite of its common use in physics, it has nothing to do with the reversal of motion, because it does not reverse the displacement. That's the point. This is a characteristic property of the reversal of motion. The fundamental difference between the two operations is that in the reversal of motion, the displacements are inverted, as one sees during the backward film projection, while in the time reversal, the displacements are not inverted. This is stated in the book. At the reversal of motion, the variable associated with the t bar, like displacement, current, heat, work, and so on, change sign, as happens for the variables associated with I tilde, such as momentum, angular momentum, magnetic flux. Particle dynamics in one dimension. Here you have the diagram in which are represented the physical variables of particle mechanics moving in one dimension and their association with the elements of the time axis. On the left you have the kinematical variables that are the abscissa and the velocity. Velocity is the derivative of x. And these elements are associated, as you can see here, with the primal time elements. On the right side, we have the dynamic variables, force and momentum. And momentum is linked to force with this equation, derivative of momentum equal force. And these elements here are associated with the dual time elements. After you have the constitutive equation, for example, an elastic force, in which the elastic force is opposite but proportional to the abscissa, to the displacement from the initial position. Another example is the link between force and velocity. The force may be linked to the velocity with this constitutive equation minus c. And this is typical of viscous force. There are also the constitutive equation, fundamental here, P equal mv. As you see, we have three kinds of equation. Here we have a variable, the kinematical variable, and on the right side, the dynamic variable. In the middle, as a link between left side and right side, you have the constitutive equations. As you see here, you have the corresponding time elements. Physical variables are associated with time elements. Which time element is associated with a physical variable? Every physical variable is associated or with a time instant or a time interval. Moreover, both of these time elements might have an inner or an outer orientation. For those variables that are measurable, the discrimination between the association to the instant or to the interval is simple. When the measuring process requires a time interval, however small, the physical variable is associated with a time interval. Thus, to measure the temperature, we need a time interval, however small, in order that the probe of the thermometer reaches by the thermal equilibrium with the body. It follows that the temperature is associated with a time interval. The velocity of a body requires a time interval, necessary to perform a displacement, however small, hence it is associated with time intervals. Every flow, a flow of charge, of mass, of energy, of momentum, makes reference to a time interval in order to be measured. Hence, a flow and a current are associated with a time interval. Rules to find the proper time association. We have 4 time elements. Primal time interval, inner orientation, these are. Dual time instant, outer orientation, these are. 1 arrow. Dual time intervals, outer orientation, here you have 2 arrows. A primal time elements, capital I bar, inner orientation, these are with 2 arrows. We give here 2 fundamental criteria. Those physical variables that change sign under reversal of motion are associated with the T bar or I tilde. Those variables for which it makes sense to perform the time integral or its rate are necessarily associated with T bar or with T tilde. The combined use of the 2 criteria permits to find the time association of every physical variable. Here you have the rule to find the proper association. Change sign under reversal motion, yes or no. Makes sense to perform the time integral or to perform the rate, yes or no. You may stop here the film to see this table, that is important. For example, force change sign, no. Can be integrated, yes, hence T tilde. Momentum change sign, yes. Can be integrated, no, hence I tilde. Work change sign, yes. Admit the rate, yes. It is a power, hence T bar. Energy change sign, no. Can be integrated, yes, hence T bar. The definite time integral of energy is the action. The indefinite time integral is the Jacobi function. Charge change sign, no. Can be integrated, no, hence I bar. Mass flow change sign, yes. Admits the rate, yes, hence T bar. Look to energy that, for a reason that will be explained later, has also the association not only with T tilde, but also with I bar. The 6 main variables of particle mechanics. Let us consider a falling stone. To make a film, show to the falling stone, and then we make a film, project on a screen the film backwards. Look here. This is a fall of the stone. A point is associated with every instant of the primal complex. the displacement with an interval, the velocity with an interval, the momentum with the dual instance. And all these variables, as we shall see, change sign when we reverse the motion. On the contrary, both the impulse of the force and the force do not change sign. Now, if we consider the backward motion, you see that the force is always toward the back, toward the bottom, and J, that is impulse also. But this variable changes sign. And this is an important factor that must be memorized. We will see the stone to go up that reverses displacement, speed and momentum. On the contrary, when the stone decelerates, then the force and the impulse, due to the gravitational attraction, are always directed downwards. Here we represent the 6 main variables: the radius vector, the displacement, that is a variation of radius vector, and the velocity, that is a rate. Of course, it is a limit of the rate in the differential formulation. And the velocity is a derivative of the radius vector. Force is associated with dual time intervals. Momentum is associated with dual time instants. The variation of momentum gives impulse, and the impulse is a definite integral of the force. As you see, the variable of one theory assume a precise position in the diagram on account of their meaning, on account also of their association, time association. Momentum P is an integral, is an indefinite time integral of force. Impulse J is a definite time integral of force. What about acceleration? Despite its great usefulness in classical mechanics, acceleration is not a key variable. In fact, it arises by combining two first-order equations and taking into account the fact that in classical mechanics the mass of a particle is constant. In relativistic mechanics, where the mass depends on the speed, the acceleration is not even mentioned. Then don't put acceleration on the same level of importance of velocity. Here we have the 6 main variables of the rotation of a rigid body with a fixed axis. The diagram is similar, and here you have angle of rotation and angular velocity. On the right side we have moment of a force, angular momentum and angular impulse, linked by definite integral. The angular momentum is an indefined integral and definite integral of the moment. The angular impulse, L of t, is the definite time integral of the moment of a force. Global variables in time. A physical variable will be called global in time when it is not the rate of the time derivative of another variable. We can also say that if the time integral of a physical variable has a physical interest, if it is already considered in physics, its time integral is a global variable in time. So the position vector, the mass, the electric charge, momentum, entropy are neither the time derivatives nor the rates of other variables. Hence, they are global variable in time. Velocity is the rate of displacement, as we have already stated. Hence, it is not a global variable. On the contrary, the displacement is a global variable. The electric current is the rate of electric charge flow. Hence, it is not global in time. The electric charge flow is global variable in time. Remark. From the mathematical standpoint, every function that depends on time can be integrated in time. But we are considering physical variables, not simply scalar or vector function. And we are considering the physical meaning of the integral in time. In other words, we are doing a physical classification, not simply a mathematical classification. Here you have the global variable, some global variable in time. Here we have global variable in time displacement, corresponding rate velocity, mass flow, mass current, impulse, force, work, power. Here the force can be integrated in time, hence it is not a global variable. The definite and indefinite time integrals correspondingly are impulse and momentum, on the contrary, are a global variable in time. The power can be integrated in time. The definite time integral is the work, and the indefinite time integral is the energy. The last are global variables in time. Also, here you have other global variables in time. You can stop here the film to see these, to analyze these. Now, other global variables in time here. As it is strange, the term temperature impulse, but it exists in the physical literature. Is the notion of thermacy that was considered by Max von Laue, de Broglie, and others. See the author book. The temperature can be integrated in time. Association with time instant. The physical variables that does not require a time interval for their definition are associated with a time instant. This is the case of position vector, Lagrangian coordinates, mass associated with a time instant, momentum of a particle or of a body, angular momentum of a system, electric charge, electric flux, magnetic flux, the velocity potential in fluid dynamics, the entropy of a system, the phase of a wave. The total displacement of a point in solid mechanics is also associated with an instant, and the strain tensor. Association with primal or dual instant. When a physical variable is associated with a time instant and change sign for the inversion of the motion, it is associated with a dual instant. Momentum. In fluid dynamics, the velocity potential and the magnetic flux density change sign is associated with an instant, the dual instant. When a physical variable is associated with a time instant and does not change sign for the reversal of motion, it is associated with the primal time elements. Here, position vector, electric charge content, mass content, these are associated with primal time instants. Association with primary dual intervals. When a physical variable is associated with a time interval and does not change sign for the reversal of motion, it is associated with a primal and dual time interval. With a dual, time interval. See, this is a case of impulse that generates force, kinetic energy, is associated with dual time interval, potential energy, internal energy, electric potential impulse and electric potential. As we shall see in a moment, the kinetic energy, potential energy and internal energy are also alternatively associated with primal time instant. This is shown later. What about energy? The work changes sign by reverses a motion because the displacement changes sign. Hence the work is a definite time integral of a force scalar product with a displacement, infinitesimal displacement that is associated with time intervals endowed with linear orientation. Hence, we have here a change of sign and here no. Hence, work changes sign. In fact, the work given to a system during the backward motion is, on the contrary, is given by the system to the exterior, is released. Power is the rate of work, it is also change sign. This t we divide by the value at t, that is the duration of the time interval, is not the time interval like the one denoted in boldface. Energy is such that the variation of energy gives a work. As you can see in this slide, the energy is associated with time instant. The present author is not able to explain this double association. Maybe there is a difference like velocity that has two descriptions, the system description and the spatial description. Hence, this at the moment is in contrast to what we have said, shown before. We have said that the energy, for example, kinetic energy, is associated with dual time intervals. What about action? The definite time integral of the Lagrangian is a Lagrangian action. Well, since the Lagrangian action does not change sign because it is a relativistic also, it is an invariant under proper and improper transformation, change of axis, and also for reversal of motion, here you see that the Lagrangian action is associated with time interval. The corresponding indefinite time integral is known as Jacobi function and is denoted by capital S. S is a Jacobi function used in analytical mechanics. Of course, we have that also the Lagrangian action referred to T by is tilde is the difference between the Jacobi function at two instants of dual instant. Hence, we see that here the Lagrangian is associated with dual instant. But Lagrangian is composed of kinetic energy and potential energy. Hence, we see once more a double association that, as we repeat, the present author is unable to explain, but surely there is some distinctions that must be made. The fact that S, the Jacobi function, is associated with dual instants here is an agreement with the fact that the momentum is associated with dual instant and with the relation, by means of the relation, capital P, vector P is a gradient of action. Here you have the summary of the present lecture, but this summary including time, it is not necessary to be read. And we have, as a last slide, a statement about Euler. Euler was one of the most famous mathematicians of the history, maybe the most famous. In the Eulogy of Euler's, it is written, he, Euler, was entirely imbued with respect to the religion, and this piety was sincere, and his devotion was full of fervor. He fulfilled with the greatest detail all the duties of a Christian. He loved everyone, and he felt stirring of indignation. It was against those enemies of religion, especially against the declared apostles of atheism, that he made a stand in the defense of revelation against the objection of atheists. It is a work which was published in Berlin in 1747. Here we stop. The author begs pardon because it is 82 years old. It has a bit difficulty in reading English. Many thanks.